Now moving to enzymes. So first of all, in enzymes we will discuss about the chemical reaction. Chemical reaction means the chemical compounds. They always undergo two types of changes. One is physical change and the other one is chemical change. Now, rate of a physical or a chemical change of a reaction refers to the amount of product formed per unit time. And how do we express it? We express it like this. Rate is equals to delta change in the product formation upon time. It can also be known as velocity. When there is a specific direction, we know that. But what are we trying to check? We are trying to check a little change in the product formation in the given time. Now this rate of reaction, it is influenced by various factors. And these factors are temperature, then basically what we say as a general thumb rule in temperature is there is every 10-degree rise or fall in temperature. If there is a 10-degree rise in temperature, the rate of a reaction doubles. If there is a 10-degree decrease, then obviously the rate, it becomes half for every 10-degree rise or fall in temperature. And second is this catalyzed chemical reactions. Catalyzed chemical reactions obviously proceed at a much faster rate than uncatalyzed ones. Alright, and you know the carbonic anhydrase, it acts as a catalyst and it increases the reaction rate by about 10 million times. Just imagine. The rate of reaction is accelerated by 10 million times because of this carbonic anhydrase. This is an example of catalyzed one. Now moving to how do enzymes function. When we talk about how do enzymes function, for every enzyme action there is always a substrate that binds at the active site within a cleft or pocket and diffuses towards this active site of enzyme. Obviously this is an enzyme. I'll write it as E. Now, this is the active site of enzyme to which the substrate binds. Alright, it basically diffuses into it and form a substrate enzyme complex. This formation of ES complex is a transient phenomena. Why do we call it a transient phenomena? Because this is a state where the new substrates are formed. It's not that the entire process will take up so easily. It's not that breaking and making thing that we have broken this piece from here and attached that piece somewhere else. No. Here so many bonds are being broken and so many new bonds are being formed. So this is a transient phenomena. A new structure of the substrate. That means the transition state structure is formed. Alright. Here transition state structure is formed. And soon the expected reaction of breaking and making of new bonds is completed. After this transition state, then breaking, making of the bonds is completed, and the structure of substrate is converted into the structure of product. There could have been many altered transition states in between the stable substrate and the stable product. This is a stable substrate. Here, this one. Alright, it undergoes so many changes. The transient phenomena, where the transition state is formed, where the breaking making of bonds is taking place, and there are many alterations. So the stable substrate then finally gets converted into a stable product. But in between they are all unstable. So we have a graph to explain the enzymatic action. See, in this graphical representation, the y-axis, it represents the potential energy. Potential energy. And the x-axis, it tells us the progress of the structural transformation. That means progress of reaction. What happens here now is, we are talking about when the substrate starts the formation into a product. Here it is. Substrate S. I would better write only S. Substrate. This is the activation energy without enzyme, because with enzyme. Without enzyme it would be somewhat like this. This is the activation energy without enzyme. This is the activation energy with enzyme. Now what is this activation energy? What is this without enzyme and with enzyme? What is this product formation? This actually is a reaction rate described in a graphical form. We see the energy level of S and P can reveal the nature of this entire reaction rate. If P is lower in level than the S, the reaction is exothermic. Okay? If P, product formation, is at a lower level, which level? Lower level compared to S, then reaction rate is exothermic. We need not to supply any extra source of energy. If P is at a higher level compared to S, then the reaction rate is endothermic. It means it needs external supply of energy. But S has to go through a much higher energy state or a transition state. Always transition state where the making breaking of the bonds is taking place. This is the transition state. This is the transition state in both exothermic and endothermic as well. Exo is when it is below this line. Endo is if it ends up somewhere here. The difference in the average energy content between the S and the P and S and the transition state, it is called activation energy. Means the difference in the average energy content between the S and the transition state is called the activation energy. This is the transition state achieved. And we have lowered the transition state by using the activation energy. We have brought the transition state here. by using activation energy. Activation energy is a kind of kickstart, you can imagine. That a little amount of energy which is required for any enzymatic action to proceed. So this activation energy, it brings down the transition state here from this point. Ultimately, this difference in the average energy content between the S and the transition state, this is the activation energy. It is brought down because of the activation energy. So the reaction will occur speedily. Transition state will not take much time. The making and breaking of bonds will quickly be observed, and ultimately the reaction rate is achieved. So the enzymes which brings down the activation energy and make the S to P, that means from substrate, stable substrate to stable product easier. It is all because of the enzymes. What do? They help in bringing down the activation energy. This is without enzyme, this is with enzyme. So automatically the reaction rate speedily occurs. This is how the enzymes function in every reaction. Clear? Now moving to nature of enzyme action. When we say nature of enzyme action, we are quite clear with what is E. Obviously, it is the enzyme. What is S? It is the substrate. Substrate always binds to the active site of enzyme. And what it forms? ES complex, enzyme substrate complex. This is a transition state, a transient complex. This complex is short-lived. Why? Because here quickly the substrate dissociates into the product formation and ultimately lead to the formation of EP complex. So the stable substrate becomes a stable product at the end of the reaction. So this unchanged enzyme releases the product, and when this takes place, the entire thing is summed up to form like this. ES. Why? Because it is a transition state. It keeps on making and breaking new bonds. Then it forms EP. Right? Then E plus P. This is stable and this is stable. Here these are in the transition state itself. Now the factors. If we say factors, the first one comes is the temperature. Enzymes generally function at a narrow range of temperature. They do not prefer too high. They obviously, that is known as the optimal range. And the temperature at which the enzymes show its maximum activity is the optimum range only. Both below and above the optimum temperature, enzyme activity decreases. See, if this is the enzyme activity, and this is the temperature, and this is the optimum. So obviously below and above the temperature, this optimum temperature zone, the enzyme activity decreases. At a low temperature, the enzyme is inactive, and at high temperature एंजाइम्स की प्रोटीन्स की हमने एक नेचर पढ़ी थी दैट दे गेट डीनेचर्ड राइट हियर द एंजाइम इट गेट्स डीनेचर्ड means not be able to show its activity. So activity is less in both the cases. If it becomes inactive, then also, and if it's denatured, then also. All right, moving to the second factor. And the second factor is effect of pH. pH, you know that each enzyme has a particular optimum pH, same way. Optimum pH means activity is maximum. Whose activity? Enzyme activity. So obviously same way, a little change in the pH, this is the enzyme activity. and this is the pH range. Optimum is the pH range, maximum is the activity of the enzyme. And changes in the pH, how will it affect? It alters the tertiary structure of the enzyme. If the tertiary structure of the enzyme got altered, automatically the enzyme activity gets decreased. This is the effect of pH, same as that of temperature. Alright, always these values, this temperature, pH helps in bringing the optimum range and where the enzyme activity is maximum. Below and above the optimum range, no enzyme activity is observed, whether it is pH or temperature.